Welcome to this video. As you might have seen in the thumbnail, in this video we are going to explore about the gamma function, and ultimately we are also going to explain how to find something like minus half factorial and why does this value bring importance and why is this value important. So we will start off with the definition of gamma function. So understand that this is a special function in integrals, and it is also associated closely with the beta function, which we'll also study in this video. And we will see how they're related together, how they're used to find out different properties. So the gamma function defined like this, gamma of s, where this symbol here is called gamma. So this is capital gamma of Greek. So it's a Greek letter, and gamma of s is defined as the integral 0 to infinity e to the power minus x into x to the power s minus 1 dx. And this is defined for all real numbers where s is greater than 0. So this is defined for all s greater than 0. And if we invoke complex numbers, the real part of s must be greater than 0. So yeah, this is also defined for complex numbers as well. Now, this integral is said to be equal for natural numbers s as s minus 1 factorial. And this is true only if s is a natural number. Now, you can understand clearly, and this can be found out easily using integration by parts. So you can do IBP on this one and find out a recurrence relation. So what is that recurrence relation? Now, the gamma function satisfies the relation gamma of s plus 1 is equals to s into gamma s. Sorry, it's not f, obviously, it's gamma s. Said in other representation, this is the much more famous one. Gamma s plus 1 by s is basically equals to gamma s. And this allows us to do something called the analytical continuation while working in the complex analysis. So something we should discuss and save it for another video. But for this video, remember this recurrence relation because this is going to be important. Now, why is this useful? So first we should need a few values of gamma function. So first of all, gamma of 1 is equals to 0 factorial from definition, which is basically 1. And moving forwards, you can find any value of gamma like this. So gamma of 2 is nothing according to the relationship 1 into gamma 1, which is nothing but 1. You can also find gamma of 4, which should be nothing but 3 into gamma 3. And again, gamma 3 would be nothing but 2 into gamma 2, which is nothing but 1. And that means it's this 3 factorial or 6. So in this way, we can find all corresponding values of gamma function for natural numbers. Now, this is the integral. So please study it carefully. 0 to infinity e to the power minus x, x to the power s minus 1 dx. And there are a lot of variants of this integral that will be used. So I'm going to show you a few of them today. So in order to begin the journey, we will also consider one more formula here, which is called as Euler's reflection formula. And this is something that enables us to find something as weird as minus half factorial, which we are going to see in a moment. So what is Euler's reflection formula? For s belongs to reals and 0 less than s less than 1. So I'm completely talking about real numbers here. So we will not mention any complex numbers in this scenario. And of course, the Euler's reflection formula right now for real numbers is only defined. So gamma of s into gamma of 1 minus s is equals to pi upon sine of pi s. Notice that we must have 0 less than s less than 1. Otherwise, this is not defined. The formula does not hold. And from this relation alone, you can find out that if you put s equals to 1 by 2, you simply get gamma of half into gamma of 1 minus half equals to pi by sine of pi by 2. Since sine of pi by 2 is equal to 1 and gamma 1 minus half is also gamma half, this allows you to conclude gamma of half squared is pi, or in other words, gamma of half, since it is positive, we will take the positive square root, is root pi. And gamma of half is root pi. According to the definition of gamma of half, you can also write this in a fun little way. So this is just a fun little way because minus half factorial does not really mean anything physically. So it will not have any notion as if as like the factorials usually have. But yes, we can write this. Gamma of half is nothing but half minus half factorial, which is equal to root pi. Therefore, we have this gamma function definition here. Now let's try and do a few integrals and see how this works out. So suppose you have the integral 0 to infinity e to the power minus ax into x to the power n dx. Now, if you remember how the gamma function looked like, this is something that resembles that form. And to make it in that form, we will substitute y equals to ax so as to make this exponent of e as e to the power minus y. And this would also give you dy is equals to a into dx. And thus the value of dx is also found. Notice that the limits remain the same. So 0 to infinity e to the power minus y, and x becomes y by a. So this is basically y to the power n by a to the power n, and dx becomes dy by a. So dy by a. Of course, we must have a greater than 0, since otherwise the integral will diverge. So we have not touched any topics of convergence or divergence yet, but just remember this, that a must be greater than 0 here. Now 0 to infinity 1 by a to the power n plus 1 outside, we have e to the power minus y into y to the power n dy. Now this is essentially the gamma function, but notice that this is gamma of n plus 1 and not gamma of n. If you remember, there was a minus 1 here in the definition of gamma function. So this would give you basically gamma of n plus 1 by a to the power n plus 1. For natural numbers, for n belongs to natural numbers, this value is simply gamma of n plus 1 by a to the power n plus 1 is nothing but n factorial by a to the power n plus 1. And that is the value of this integral. Let us try another example here. Number 2, 0 to infinity. Now we have x to the power a upon a to the power x dx. And we of course again have a greater than 0. And what is the value of this integral? Now 0 to infinity x to the power a by a to the power x dx, we can first write down like this. This a to the power x can be brought upwards, and it can be written like this: a to the power minus x into x to the power a dx. Now again, a to the power minus 1 whole to the power x is nothing but e to the power x log of a inverse, where log is natural logarithm, and this is again nothing but e to the power minus x into log a. So we will apply this and write this integral as 0 to infinity e to the power minus x into ln a into x to the power a minus 1, a plus 1 minus 1 dx, where we have written this in the form of the gamma function. And we already know if there is an extra coefficient multiplied with the x in the exponent of exponential in the gamma function, that basically comes out, and using the previous result, you can simply write the answer as gamma of n plus 1 by a to the power n plus 1. So now simply this would be nothing but gamma of a plus 1 divided by ln a to the power a plus 1. Or if a is a natural number, you can simply write a factorial by ln a to the power a plus 1, given that a is a natural number. So this completes another example. Now, there are so many different examples that you can understand, and one special kind of integral that has appeared in a lot of exams, which is based on this one, was this 0 to infinity x to the power 7 by 7 to the power x dx. And this was nothing but, as you can understand, 7 factorial by ln of 7 whole to the power 8, directly from our formula. So this is how the gamma function works, and this is how factorials in general will work. And if you have anything related to the exponents where you have 0 less than s less than 1, you can always go back and apply the Euler's reflection formula. In the next video, we shall talk about beta functions, and then we can connect these two and find out a lot more interesting stuff about how to evaluate integrals fast, and how to even do some sine and cosine integrals, which can be evaluated directly from this gamma function, also including the Wallis product. If you are new to the channel, please do subscribe. Thanks.